right, so in this video, we're going to find the unit tangent vector of a given curve. Now, this curve, as you can see, r of t is given as 3 components, so it's a space curve. And we're going to find the unit tangent vector at t equals pi over 4. So let's take a look at how this is going to work. So we know that t hat, so it's going to be tangent to our space curve at that t value. So we're going to make this a unit tangent vector. So this is going to be the derivative of r of t divided by the magnitude of that vector, because that's how you make a vector a unit vector. So we're going to take that and take its magnitude. That is by definition a unit tangent vector to a curve. Now you could do the same thing with two-dimensional curve, except you'll have two components for r of t rather 3. So let's plug in the t values. So our unit tangent vector will be at pi over 4. So we'll be evaluating our derivative function at pi over 4. And then we're going to divide that by its magnitude. So that's how we're going to compute it. So let's take a look at what the numerator would be for this curve r of t. So r of t is given as cosine t, t sine t. So we're going to take its derivative component-wise. So r prime of t, it's going to be derivative of cosine, that's negative sine of t. Derivative of t respect to t, that would be 1. Derivative of sine of t would be cosine of t. So that is our r prime of t. Now we want to plug in our t value. So we're going to evaluate our derivative at t equals pi over 4. So plug in pi over 4 in place of t. So this is going to evaluate to negative sine of pi over 4. 1, that's just 1. There's no t to input. And then we'll evaluate cosine of pi over 4. And then this will evaluate to, we know sine of pi over 4, that's 1 over a negative in this case, 1 over square root of 2, or you can rationalize it, square root of 2 over 2. And then our y component is 1. And then the z component cosine of pi over 2 is also 1 over square root of 2. So that's our r prime at pi over 4. So that will be the piece we're going to put in the numerator of this. Now for the denominator, we're going to find the magnitude of this vector r prime at pi over 4. So let's now take its magnitude. So the magnitude would be the following. So I take r prime at pi over 4. I take that vector and find its magnitude. So that's going to be the square root of each component square, and then we add them up. So we'll do the first component, negative 1 over square root of 2 squared, plus 1 squared, plus the third component, 1 over square root of 2 squared. All right, let's evaluate this. So this is going to be the square root of negative 1 over square root of 2 squared. That's just going to be 1 over 2. 1 squared, that's 1. And then the last term will also get 1 over 2. And if you add them up, so you're going to have half plus a half, that's it. 2 over 2, that's a 1, plus 1, that's 2, so square root of 2. All right, now let's piece them together. So this is our numerator of the tangent vector, and this is the denominator. So our unit tangent vector, it's going to be our r prime at pi over 4, that's negative 1 over square root of 2, 1, and 1 over square root of 2. We divide that by its magnitude, square root of 2. And you can simplify things, make it look prettier. But if you can get to this far, this is really good. Now, let's play around with it and just practice a little. Now, if you want, you can just rewrite things this way. This is really 1 over square root of 2 times our vector. It's 1 over square root of 2, comma 1, comma 1 over square root of 2. So that's how you just rewrite things. And then if we distribute 1 over square root of 2, we'll have negative 1 over 2, and then 1 over square root of 2, and positive 1 over 2. So that's another way you can write the same vector. All right, I hope this idea makes sense. I'll see you next time. Take care, guys.